Welcome back. So I'm going to be working on now just using all the stuff on here just because we know how to use them individually. Now let's just bring everything together. So what do we have on here again? I think we have a green LED, a red LED. We have the resistors for both of those LEDs. I also have a buzzer there that should be working. I have the I2C adapter here and I have the LCD here. So what I'm going to be doing in this one, let me go back to my screen. What I'm going to be doing in this one is, let's say, get temperature. I'm going to turn, let's say, turn on red LED if temp is below, let's just say 20 for argument's sake. I might change that later on. We don't need to, actually, yeah, let's sound buzzer as well. Sound buzzer, put to LCD. So what that means is if the temperature falls below a certain value, I want to be alerted, and I want to be alerted in an audible manner, which is going to be the buzzer. So I need to hear a sound, and I want to also see a visual representation of this, which is going to be the LCD and the LED at the same time. Let me put LED as well. That's going to be red LED on, and I'm going to do the complete opposite now for the other one. So turn, oh, I already said LED at the beginning, apologies. Turn on green LED if temp is above, let's say 20 then, yeah? Don't sound the buzzer, but I need to put to LCD. The buzzer only needs to go on when the system is like gone off, when it's really cold, right? So imagine you're in Antarctica and you're someone who can't really see well, but you can hear amazingly well. If a buzzer goes off, you know, okay, whoa, the heating system's gone down. We need to do something about this ASAP. So something similar to that. And these are the actions we're going to do. So I think the main thing, the main input to this system, well, the only input to this system is going to be get temperature. So let me save this to the Raspberry Pi for now. Let's call this temp LCD LED buzzer. Is there anything else? I don't think so. .py. This is going to be number 10. And what I'm going to do is open my PowerPoint. I think I said PowerPoint first, so block diagrams. I believe so. Let's get rid of all of this. And my block diagram, go to insert, go to shapes. I'm going to go to rounded rectangle somewhere here. I'm going to go to, what was this one again? Input. And the input is going to be temperature sensor, right? Then I'm going to have the processing, which is going to be pi, let me just say pi Pico. Let's be lazy. Oh, Pico. Let's zoom in. And the output is going to be, well, quite a few outputs in this case. We're going to have, I'm going to separate them just because. I'm going to say LEDs, so that's both green and red. Then I'm going to say LCD, liquid crystal display. Then I'm going to also say buzzer. Now, keep in mind, input devices send information into the system. Output devices get some information out of the system so we as humans can understand what's actually going on. What other output device do I have? LED, buzzer, LCD. I believe that's it. So I'm going to go back to insert. I'm going to go to text box. This is going to be my input. Oh, not pit, input. I'm going to copy this a few more times. This is going to be my processing, PROCSSING. This is going to be my output over here. And I only need to connect these now. So go back to insert, go to shapes, and I prefer to use the elbow arrow. Use whichever one you prefer. I'm going to make this one thick. So I'm going to go to shape outline. I'm going to go down to where it says weight. I'm going to make this about 4.5, seems fine. Yep. I'm going to copy this, paste it a few times. That one there, like so. Copy again. Let's put that one there. Bring that one down to the LCD, paste another one, move this down here, connect this from the Pi Pico and bring it down here. And that's it. So I've got my input device, single input device, which is the temperature sensor. I've got my processing, which is my Raspberry Pi Pico, and I've got my output. So for people doing the Unit 6 exam, again, you don't have to use a Raspberry Pi Pico. This could also be, what's it called again? This is called Arduino, ARDUINO, Arduino Uno, Arduino Mega, whichever one you want to use. You could use a PIC microcontroller. There's so many devices that you could use. So whichever your school is allowing you to use or whichever you've chosen to use, that's fine. Now, I do highly recommend that you save your documents as, for example, I'm going to save this as a PDF. So I just have it in case I need to edit something later on. I'm going to save it as a PNG so I can put that PNG into my document if I really wanted to. And I'm going to also save it as a PDF and leave all those files in there. I would just leave everything in there. So if for some reason your document messes up and they don't actually see what's in the document or it's too small, they can always go open the PowerPoint. That's number one. Number two, the PNGs there, they can open that as well. But most devices work really well with PDF. So they could simply go open the PDF file, zoom in as much as they want and see it. Okay, so let me create my Word document. So for most of you guys, right click if you're using Windows, go to new, and I'm going to choose Microsoft Word document. What was this called again? Oh Lord, LCD, LED, BUZZER, something along those lines. Go in here, got it. What I'm going to do, I'm going to simply insert my block diagram in here. Now you can screenshot it by going Windows flag on your keyboard, Shift and S, and then you simply highlight this entire section here. You can then go back to your Word document and simply paste it. Right, so that's what I'm going to do for now. Let's move this down first. So I need to have at the top parts, again, parts and justification. Everything that you guys test for Unit 6 from now on, I suggest you have your parts list. So I'm going to have I2C adapter. I'm also going to have red LED. We're going to have green LED. We're going to have Pico. We're going to have 16 by 02 LCD. I don't think I had any. Oh, BUZZER. What else do I have on there? I don't think I have anything else. In any case, oh, resistors, my bad. And parts and justification. Make a parts list. This is something you have to do in the exam as well. Make a parts list and specify why you decided to use that part. I2C adapter connects to the Raspberry Pi Pico and to the LCD, allows me to use only 2 pins versus the 12 or 16 I would use if I had to connect the Pi Pico directly to the LCD. Red LED is going to be used in this case just to show when the system is doing the pre-programmed negative thing for me. And my pre-programmed negative thing is going to be if it's too cold, turn the red LED on because I don't like the cold, right? My green LED is going to show the pre-programmed positive thing. So if the temperature is what I want it to be, then fine, show the green LED at all times. The Raspberry Pi Pico, that's the microcontroller I'm going to be using to control the rest of the devices. And again, a microcontroller, I don't know why I'm doing this now, but randomly, microcontrollers are used to control other devices, hence the name microcontroller. So it just means small controller, that's all it means. Next, we have the 16 by 2 or 16x02 LCD. That just means it has 16 columns and 2 rows. In total, we have 32 characters. And next we have a buzzer. Is going to be used as an audible device, obviously, because it's a buzzer, and it's going to be the audio representation of what the system is doing. So if it gets too cold, I want it to buzz. I don't like the cold, so I need to know straight away, and it should start buzzing. We have our resistors, which limits the flow of current across devices in order to protect them. The Raspberry Pi Pico gives off 3.3 volts from those GPIO pins. The LEDs themselves use roughly 2 volts for each one, and that's how you can calculate your resistance. So use the PIR formula, so the power calculation or the resistor calculation formula, whichever one you want to use, and that's the justification for my specific parts. Now the next thing I need to do, I've done my block diagram. Oh, have I done a circuit diagram? I don't think so. So let me go into Fritzing and do a circuit diagram now. So here I am in Fritzing, need to do my circuit diagram. I already have my LCD from the previous one. I now need to connect my buzzer. So let me go to where's parts. So I don't want to do that. Let's click on that all the way up. Go to the search bar at the top there. I'm going to type in BUZZER, buzzer. Press enter to search. Whichever one comes out. This is the one I used the last time, I believe. And I think the pin I used for that one was pin 20. Yep. So let me click on that. Let me rotate and flip this 180 degrees. Connect this here. And I can probably put that here. So what I'll do, I'll draw a connection. Let me zoom in. I'll draw a connection all the way from pin 20. Click and hold, drag, drag, drag onto the red one. So I can trigger it with that pin. And for ground, I'll just go from there to there. So you know what, I'll leave it as it is. So that's it. And for the LEDs, I use pin 21 and pin 22 at the very top here. So let me go look for some LEDs in the search bar again. Type LED. The red one normally comes up, I believe. Yep, there we go. Click on that. Now I'm going to click on it. I'm going to go down to flip. I'm going to flip horizontal. Reason being, I just like it flipped that way so I can go directly from my Raspberry Pi Pico into the LED. Then I'm going to also need a resistor, R-E-S-I-S-T-O-R, in the search bar. Grab whichever one you want because you can change the value later on. So let's copy the LED first. So click on it once. Do Control C on your keyboard and then Control V to paste, then move it where you want it. I think you can right click and copy as well, yeah, or duplicate. There we go, Control D to duplicate. So I could have just done that as well. So if you click on it and do Control D, it just gives you another one straight away. I'm going to do that for the resistor as well. Actually, let me change the value of the resistor first. So let's work for myself. Down here where it says resistance, so the properties on the right hand side, click on the drop down menu and go to 330 ohms. I think that's what I used on my breadboard, so I'll just use that for now. 220 should be fine for the Pi Pico, because what I think when I calculated it, it should be like 65 ohms. If you have a higher value resistor, it's just going to be dimmer than it's supposed to be, but that's perfectly fine for most cases. Now again, click on the resistor, do Control D to duplicate and move it to where you want it. I'm going to click on my second LED. I'm going to change this to green. I kind of like the darker green, so I think it's one of those ones. Yeah, I'll take that one. Now, pin 21 on my breadboard is the green one, so this actually needs to be in front. And pin 22 is going to be that one. So the way I would do this, let's click on the LED, the resistor, sorry. Let's do rotate. Let's do, oh no, it doesn't actually allow me to flip it, huh? Let's see if there's anything I can do about that. No, it doesn't. Well, that's annoying, because flipping the resistor would be very useful, because I could simply plug it onto here and then it would just go directly up there, but that's fine. What I can do instead is do this. So connect, let me zoom in and see if that's connected. I don't know if this actually connects. Does it connect? I think so. Let's just draw the wire in it anyway. So go from my pin 21. Let's drag this over. Again, scroll up to zoom in, scroll down to zoom out. You can highlight multiple things and move it. I'm going to go directly from my breadboard into my resistor like so. And once that's connected, I think once I move that resistor, the line should move as well. Yeah, I was right. Connect that directly to my resistor. Then do the same thing for this one. Now, I'm going to probably put my one a bit higher or a bit lower just so it doesn't interfere with the circuit diagram itself. So I'm going to go here. I'm going to put that one there. I'm going to go from pin 21 over to this one here. I'm going to draw my line like so. And as you can see, it crosses over. But let me change the color of this one so it's very obvious. Maybe to yellow. Yellow is fine. Yep, that's fine. So that one crosses over. And both these LEDs now need to go to ground. Ooh, that's going to be a bit sticky. So what can I do? Let me steal a ground rail from the bottom. So I'm going to move that temporarily, grab that one down there, connect it to the top one there. Oh, let's change that back to blue actually. Let's change that to blue. Drag that one up there so we have the ground rail at the top connected as well. You can do this any which way you want. I just like my circuit diagrams being very, very neat. So this is how I prefer to do it. Let's do this first. Connect that one to there and then connect that one to, oh, that's the wrong one. So the one I'm supposed to connect is the bottom one. That's the ground rail. So connect that one to the top one there and connect that one to the bottom one there. And that's it. I have my components in my diagram. Let's bend this around. Where can I bend this? Can I bend this around anything? Let's see if I can bend it around. Okay, let's delete that one. Let's do this instead and connect it that way. And I'm going to bend it around this LED if I can. So do that first. Oh, 1 second. Then I'm going to do this. Then I'm going to do that. Again, this is not something you need to. This is just me being silly, right? So as you can see, everything is connected now. What else do I need connected? I've got my buzzer, got my LCD, I've got my LEDs as well. I don't think I need anything else connected. And remember, this one down here is going to ground at the top. So that top rail is going to be for the 5 volts, I think, and the bottom one is going to be for ground. I don't think I need anything else connected. If I've made a mistake, please feel free to put it in the description. I am perfectly okay with that. My buzzer's connected. Yep. Okay, so now I have this. I can go and open my Word document. So let's go back to my folder here. Let's go to my Word document, and I'm going to put my circuit diagram in here. Now, the reason I'm showing all these processes, this is stuff you have to do in the exam, so I might as well show it. Let's zoom in, drag this across, and again, I can do my screenshot by going Windows flag, Shift and S, and simply dragging over the area I want. I can always crop it later on, so if you grab extra pieces, don't worry too much. I'm going to grab that. I'm going to go back to my Word document, and I'm going to paste that there. Oh, paste that there, and that's my circuit diagram. I think that's completed. So now I need to jump over to Thunny. Oh, I didn't do my pin connections. Pin connections. Oh, this is going to be a long one. Okay, let's go. Let's do buzzer first. Buzzer. So we have pin 20 of Pico goes to high, or just goes to buzzer. Goes to buzzer. Pin 3 of pi Pico goes to ground line, or ground pin of buzzer. Pin of buzzer goes to high pin of buzzer. That's for buzzer. Then we're going to do what's next? LEDs. LEDs, we have pin 21 of pi Pico goes to 330 ohm resistor, then to LED. That's one. Then pin 22 of, let me just copy this because I'm lazy. Change that to pin 22 of pi Pico. It goes to, I think it's green. It doesn't really matter which one it is. Goes to green LED. Then to pin 3 of pi Pico, because I've said pin 3 is my ground. And if I zoom in on my Fritzing diagram, I've connected all my ground pins to that one there. Actually, what I could have done, I could have actually added a ground from here to here, so it wouldn't have to connect that one, but it really doesn't matter. I don't like the fact that this has 8 ground pins. I think it's a bit of a waste, but hey. What else do I need? Same thing here. Copy paste that. All right, what else do I need? LEDs, LCD next, maybe. So let's do LCD and I2C adapter. So VCC goes to pin 40 of the pi Pico, PICO goes to VCC of the I2C ADAPTER. We can say pin 3 of the pi Pico goes to GND, or ground. Let's just say ground. Ground of the I2C ADAPTER. SDA, I believe it's called. Pin 6 of the pi Pico goes to the SDA pin of the I2C ADAPTER. And pin 7 of the pi Pico goes to the SCL, serial clock, yeah? Serial clock pin of the I2C ADAPTER. What else do I have connected? Buzzer, yeah, done. LEDs, just did that. And LCD, that's done as well. I believe that's everything. Again, if I've left anything off, please feel free to tell me. That's fine. I'm only human. I make loads of mistakes all the time, as you guys can clearly see. Let's make that bold. Why not? And I believe that's it. The first thing I need to do is to create an empty folder. I've added my comments already. I did that before. Now, the next thing I want to do is just to get my temperature sensor stuff in. Because I've already done this code like 4 or 5 times, I'm simply going to copy this into the program I currently have. So highlight everything, Control C to copy, come back here. I'm going to put it maybe after this one, paste it there. I'm going to run this just to make sure everything works fine. So press F5. Yeah, I'm getting some temperature on screen here. That's perfectly okay. I'm going to stop that. Now I have my temperature working. I have my infinite for loop here as well. Now this is where I can start adding stuff. So the first thing I want to do is to control the LEDs. So for me to do that, I'm going to go back to one of my previous programs, and I believe I had it on number 7. So I'm going to create my LEDs here. So let me just copy that. Now, where do you put this in your program? You need to define something before you use it. You have to declare your variables before you use them. So what I like to do, I like to declare stuff right after the import statements. So let me just put that one down here, for example. I've said green LED pin 16, red LED pin 17. So even though I say pin here, it's actually GPIO, because pin 17 on the board is not that actual one. So it's GPIO 16 and 17. So I've got my LEDs there. Let's get my LEDs flashing now. So I'm going to say in my code, oh, what did I do? Let's move that. I'm going to say if temperature, so if temperature is, oh, I guess I have to press tab. Yeah, if temperature is less than 22, I want to print on screen green, it should be red LED actually, red LED on. It should come on anyway. I want to also put the buzzer, which is onto pin 15. So let me grab my buzzer stuff as well. So copy that, go back to my main code, and under this I'm going to put buzzer here. So this is where I define my temperature sensor stuff. This is where I define the LED stuff, and this is where I define the buzzer stuff. But again, I will share this with you guys. Let me press that and go out to there. The next thing I have is buzzer, BUZZER, buzzer dot high. No, this is high. It should be high if the red LED goes on. So if the temperature is lower than it should be, the red LED should come on, the buzzer should come on. That's fine. Let's sleep. Sleep for what, 1 second seems like a good enough time. Oh, it's utime.sleep this time. So utime.sleep. That seems fine. Now I'm going to do an elif statement. ELIF. Temperature is greater than 22. Then I'm going to do the opposite. So what I'm going to do here is I'm going to say print green LED on. Let's put a full stop in these. And buzzer needs to be low. The buzzer does not need to be on if everything is okay. Buzzer dot low. That's it. And let's sleep for another second. Utime dot sleep. Let's do, you know what, let's do half. Yeah, 1 second's fine actually. So those are my main checks. I'm going to do an else as well, just to catch anything else. I'm going to maybe print there was an error. So I realized I made a mistake before. I didn't actually have my LED stuff in. So I declared my LED variables, but I didn't use the actual LEDs. So I've done that now. So hopefully they should work. I'm going to press F5 on my keyboard. Now keep an eye on the LEDs first. The buzzer should work as well. Did I turn the buzzer on? I think I did. Yes, so I'm going to press F5 on my keyboard. Let's see what happens. Yeah, green LED is coming on. Everything is all good. Everything is all gravy. Yep, there we go. Everything's working now. So I just need to get my LCD stuff in. So I need to import these 3 things here. So this is just from a program that was working before. I don't want to keep typing stuff over and over again. So I'm going to copy these 3 things in, because I believe that's all I need for now. I'm going to go here, go to the very top of my program, and I'm going to paste it at the very bottom of the import stuff. But again, everything that says import or from this import, that must be at the very top of your program before you start writing any code. That's ideally where you should want to put it. And then after that, I'm going to grab all the setup stuff for the LCD. So all I need are these 5 lines here. Again, I'm going to put that just after the imports. So maybe I could put that, let's just say here, that's fine. Paste that there. My LCD stuff is now all good to go. So what I need to do now is to put stuff to my LCD based on the temperature. So to do that, I'm simply going to go back, and I believe I had it here. Yeah, I'm going to clear the screen, and then I'm going to put some string to the screen. Well, it won't be a string in this instance, but it's just going to be the number from the actual temperature sensor. So let's clear that. Maybe I should put that inside. Move this in. Let's remove all of this junk here. And let's say str. And let's put in here temperature. And that should convert my temperature to a string. So, and then at the front of this, I could probably add temp. Oh, let's put quotes first. Let's put a plus sign. Let's put temp. This should work fine. And then what else? Let me move the sleep. I think I put the sleep in the wrong place actually. So let's cut that from there. Let's paste that under here so everything now works as it should, hopefully. After that, I need to do exactly the same thing for the bottom one. So I need to put the temperature on screen regardless of what the temperature is. Now, there is another way I could do this. I could just put this at the very top of the while loop here, regardless of what the temperature is. That's probably your best option. But you know what? Let's try it this way first and see what happens. It's probably going to flash like really quickly and flash loads of times. But let's see anyway. And if anything, I can always come back and change it. Temperature there. Let's add those two things together. Let's move the sleep from here. And let's put it at the very bottom here. Let's go back there, and I believe this should work. Let me move this out. I like things being lined up properly. All right, so let me run this program now and see what happens. Let's see. Yeah, there we go. Temperature is 22 point whatever that is. I made one mistake. I didn't clear. Let me stop running this program. I didn't clear this one. That's why you see the stuff that was on screen before coming up again. So I need to clear the screen or the LCD before I write anything else to it. So let me copy this one that says LCD clear and put it just before. Now when I run that program, we shouldn't have the same issue. So again, the issue is we have previous stuff on the screen that was there from the previous run. So now when I run it, press F5 on my keyboard. I run it. It should only have that one line now, temperature that, and it should keep refreshing. That's not too bad actually. Yeah, that should be fine. But a better way to do this, let me just stop this program. A better way to do this would probably be to have this within the while loop, but outside of the if statements, so that it's just there regardless of what the temperature is. Because I'm saying, put something on this LCD if the temperature is below this, or put it on the screen if temperature is above that. But it really doesn't matter. I just always want it on screen, so I might as well put it here. So if I highlight this, and I think it's Shift Tab to move back and move that one in, I can remove this part here because it doesn't really matter again what value the temperature is. Let me run this again. That should still work, hopefully. Yeah, there we go. Whatever the temperature is, I get the value on screen. So that's it. That's our program actually done.